Welcome to the Windy City. Chicago is a huge city with 234 square miles of land and over 2 million residents. In fact, it's the third largest city in the United States. There's a ton of history here. It's full of architectural wonders and some of the best pizza you can eat. Perhaps more surprising is that it's home to over 5 million square feet of data center space, and today we're going to take a look. Hello and welcome back to Learn Linux TV. I'm here in Chicago on location, and what I'm going to do today is film the inside of a data center. It's going to be awesome. And I'm really excited for this video because I've been invited into a real data center, and this is something that really doesn't happen on this channel quite often, and I understand why. Security is really important in a place like this. In fact, I had to go through all kinds of security just to get to this point and walk down an endless hallway. But the thing is, it's not very common for companies to, just let anyone in their data center. But BigScoots invited me into their data center, and you're going to see it in this video. And this data center is located in Chicago, but you might be wondering, why Chicago? Well, why not? Chicago is awesome. There's so much to do. There's a lot of great food to enjoy, Chicago deep dish pizza, for example, and there's buildings with interesting architecture as far as the eye can see. There's also a giant bean. Yeah. Another interesting thing about Chicago is its filming history, with popular movies having been filmed here. In fact, one of my favorite TV shows, Early Edition, was also filmed here. What you see right here is the front of a building that was used for a recurring place within the show. However, delicious deep dish pizza and an amazing skyline aren't the only interesting things about this place. For us, there's something really special going on here. Chicago is actually a haven for data centers, like this one. And one of the reasons why this is the case is because railways are very prominent here in Chicago. Some of the earlier fiber lines are run along the tracks, and in addition, several internet backbones converge here as well. In fact, the building that I'm in today is known as a carrier hotel, and these are really cool. What that means is several carriers converge right here in this building, and in this building in particular, over 200 carriers converge here. That means if your data center is also located here, you have access to some of the lowest latencies you could possibly get. BigScoots is a company that provides a fully managed hosting solution for WordPress with over 17,000 websites calling their data center home. The company was nice enough to invite me inside to check out their data center, and that's where I met James.
Yeah, so my name is James Webb. I am the COO of BigScoots. My job as a COO is to make sure operationally things run well. But also, I've been in the hosting industry for now about, I think, around 20 years, maybe 15, 20 years, somewhere around there. I have an interest in how things work. So it's odd, like one day you're going to find me in a strategy meeting or in a board meeting, and the next day I'm building crash carts for the data center or, running fiber or whatever it is. So I always have this kind of like, strategy, business slash, I call it like a technical hands-on slash customer service, customer success or client success side of me. So I think that maybe that happens to a lot of CEOs in this industry. We kind of like, we're kind of many hats. We wear many hats. I think that's just kind of a hosting thing in general. But yeah, that's kind of me in a nutshell.
And much like Chicago itself, the building in which BigScoots houses its data center has some incredible history of its own. From the outside of the building, you wouldn't even know that some very popular websites are hosted right here.
So one of the little bit of odd trivia facts about the building, actually this whole area in Chicago is referred to as Printer's Row. And so there were a lot of printing presses down here and go back like 100 years or more. And this particular building was owned by Arnold Donnelly, and they printed all the Sears catalogs out of this facility. And so I always kind of find it kind of like, I don't know, like romantically weird that, back 100 years ago, they were printing these catalogs and it was all this media that was being, produced here and then shipped across the country. And then, now we're in a much different time, obviously, and it's turned into a data center. There are a lot of data centers in the area that are in a similar situation, and it's still producing media, right? So it's still creating content or pushing content throughout the entire country, throughout the entire world. And so to me, it's kind of interesting to see that, like, you have this space that was built for distribution of media, and we're still in a realm where that infrastructure is perfectly suited, albeit with different power and whatnot, but it's still suited from like a floor loading perspective and from just an industrial perspective to still push that media out to the rest of the world.
So why is it exactly that this building in particular is a good fit for that kind of thing?
It's really just the heavy duty infrastructure, right? So you have, when you think about all the high power needs, you think about the floor load, floor loading capacity, how many pounds per square foot can the data center withstand? You need that. You need that for this big infrastructure. We look at a cab out there. You fill up an entire cab, and you're looking at thousands upon thousands of pounds in a single cabinet. It doesn't seem like much when you think about single servers, but when you start adding the weight of the cabinet, the PDUs, the servers, every little component makes a difference. And then you're talking about hundreds of cabinets out there, right, or more, right? So that really adds up.
As you navigate past security and travel down endless hallways that almost seem like the endless hallways from people's dreams, you eventually navigate the labyrinth and end up here, the BigScoots Datacenter. Right here in this data center, some of the largest websites in the world are hosted. Some of them are so big, in fact, that I'm literally not even allowed to tell you who they are. Now, the BigScoots website does mention some popular clients of theirs, but the ones that aren't listed on the site are among the largest.
So obviously no easy task. So when you're looking at 17,000 plus clients, that's a lot of sites to take care of. But on our side, what we've done is it's not just like a set it and forget it and just be like in a reactionary situation. We like to use the word proactive. I think a lot of hosting companies do, but truly on our side, the only way to scale and keep control and keep those sites operating is to build the tools around it, right? So we, internally we have our own development team, and we build our own portal to watch these things. And not only is there a portal for the clients, but internally we have a portal that our own admins use. So we were able to alert on page load times, or it might be like a site or server offline, whatever it is. We have processes in place to take action on those things. And so one thing that surprises a lot of people is that when there's a problem with a site or a server or whatever it might be, they don't have to submit a ticket, right? We submit a ticket for them. So you're going to get literally from one of our admins, we're going to say, hey, your site is having this problem. We're on it. We're working on it right now. And by not only keeping ahead of those things by being proactive, but also by reaching out to the clients, they know that we're going to actually be there to take care of them, and we're not just trying to hide behind the veil of, oh my gosh, I didn't know what was going on. So I guess that kind of staying ahead of things helps minimize problems. But then also we talked a lot about data center, right? So operating your own data center space, we have full control over that hardware, the hardware refresh cycles, insight as to what's going on, having people on the floor. We're in the data center right now in our office, and so having those things in place also helps you manage the deployments at scale.
BigScoots isn't the only client utilizing the building that I visited for server space. Other companies have located their data center here as well, with the fact that it's a carrier hotel increasing its appeal. So, as you can imagine, when you have a building full of servers, keeping things cool is very important.
Yeah, so keeping these servers cool is really important, and a big component of that is
this water tank.
When you think about power being utilized, there is we'll call it it's not off-gassing, but if you think about power being used, that equals heat. And so if you have a kilowatt, 2 kilowatts, 10 kilowatts, 30 kilowatts of power being used, you need to efficiently remove that from the area so that you can keep the servers running healthily, right? We always, I guess, when I talk about my personal computers, you're always looking at if you're overclocking, or if you're just trying to tune your computer, that heat management is a big deal. So whether you liquid cool that or air cool it, well, we have to do something with the heat in the data center. It's not enough just to blow around the wind of the heat, right? We have to remove that, and so there are a few different ways to do that. But essentially, it becomes almost like a heat pump. So the data center will push that air from cold aisle through the servers into the hot aisle, which then is taken into, I'll just call it a heat pump for sake of simplicity, and then that moves outside to a 2.1 million gallon tank that it basically cools that brine water out there. And yeah, that's basically how it works. So you have to remove. I mean, you think about the size of the building. There are it's 1.1 million square feet in the building, and you can imagine each cabinet using anywhere from 3 kilowatts to 30 kilowatts of power. When you think about that square footage and that amount of power, that's a lot of heat.
Yeah. So all of our power is delivered via bus above. So this is typical for most data centers. But you're dropping 2 circuits, redundant circuits, down into the cabs themselves, right? So you're going to have a true A, you can see right there, A, and a true B. And what's nice about the way the data center does it is that it's not just like more power. You have a separate PDU, right? So like these units out here, they're separate PDUs, separate diesel generators, separate like everything back to the utility. It's separate utility feeds into the actual building. So that all kind of goes down the line so that if something were to fail anywhere along the line, you have the secondary circuit that will take over. Overall, it's not, throughout, when you go down this aisle here, you'll see this basically the way they're named here. We have a total of 6 completely separate circuits across our data center space, right? So what that means is that even if there was a PDU that blew in one area, it might only affect a few cabs on one circuit, right? Whereas redundancy for the rest of the cabs be completely unaffected. And if you walk on this way, I can show you maybe what the actual PDUs for cabs look like. Put it in the core cab. So you see the 2 up there come down, left and right. So all this equipment here, when you look at our equipment, 4 separate ports of redundancy. So 4 PSUs on the spine. And then what we do is we balance that out over. So one, they're split between both of the PDUs here. But then also we try to split. If there's on one PDU on one side, we try to split that into separate banks, right? So again, if a bank blew on one side, you still have the other's half on a different bank, and of course that's split into separate PDUs again. So it's confusing, but it's not. If that makes any sense. One thing people don't talk about often, it may sound even a little bit scary, is that in data centers they do inject humidity into the air. It actually reduces static electricity, right? So keeping that at bay helps, obviously with issues with, static frying parts or whatever. But a lot of people don't realize that there's actual humidity injected into the air to balance it at a data center. Every data center comes complete with ugly lights, ugly fluorescent lights. It's the way it is. 5 fans across the back. And what's nice about the equipment that you use in the data center, as opposed to maybe what I'm used to at home, is that every part's made to be hot swappable, right? So if I were to go, I'm not going to do it now, but if I were to go in here, I could pull these 2 out while it's in operation, pull out a PSU, and swap it back in, and nothing ever goes offline. You can essentially maintain and repair to a certain extent the hardware. Ideally, I would love to see that on a consumer side for everything. There was a time when, I don't know if you remember SGI. So the SGI Octane, it allowed you to take out the motherboard. You could swap out, daughter cards, video cards, all kinds of stuff. I would love to see us get back to the, I guess you'd call it maybe that kind of runs into the right to repair as well. I think that we've kind of lost sight of that. Everything's so disposable these days. So. But not in data center. The data center has to be highly available at all times.
With all these clients, you must have some pretty clever solutions to help manage this.
The crash cart.
The what?
The crash cart, yep.
Yeah, so we actually keep a crash cart in the called the cage, right? The cages here at the data center. We utilize the crash cart to quickly diagnose issues that are happening from a physical perspective. So if there's something that we can't get to over IPMI or over, if you want to call it BMC, or even remote SSH. If we can't get to the server, then the last resort is to get in with a crash cart. And so, in most scenarios, a crash cart is going to be, most crash carts are dumb crash carts, which means that you just have, a VGA plug you have a USB for the keyboard, and you plug it in, and you go and you try to diagnose it. Just knowing that a majority of our team is remote. I mean, we do have an office here. This is our office. We do have a physical space. So we do have people that, a tech that will pull that crash cart out there. But we also determined early on that we wanted to have remote access to that crash cart at the same time. And that's kind of where the Pi KVM came into play here. So we're able with the Pi KVM to do kind of a pass-through on video and allow the local operator to actually diagnose the issue. But then our engineers that are remote can then also see what's happening in real time. So if they need to reboot the server and go into the BIOS, they need to reconfigure RAID cards or whatever it might be that happens outside of the OS, they can go in there and do that. And so we found that the Pi KVM was able to allow us to do more than just a standard KVM over IP or what I would call a dumb crash cart.
So I noticed that there's 2 displays on the crash cart. What are those used for?
Absolutely, yes. We do have 2 monitors on the crash cart. One of them is for the diagnosing side, so we're trying to figure out what's going on the server. But then we thought about maybe we should make it a little better, and so we put a second monitor on the crash cart, and that is just another. It's like another Raspberry Pi essentially, and what that does is it logs into Slack in kiosk mode in Ubuntu, so that who's ever using the crash cart, it's kind of like a foolproof system, right? They plug in the crash cart, everything powers up, they can access everything, they're in person, access everything remotely, and then communicate issues or what they're seeing or what their ideas are back to Slack. That's actually our company Slack channel, or one of the company Slack channels. And so if you have that ability to communicate in real time while you're diagnosing, then you're not having to run back to the office and being like, hey, this didn't work, what should I try next? Or, if we have another, employee that's trying to, maybe they're trying to, I don't know, they're trying to call someone on the phone, right? Calling one of our engineers. It just doesn't work as well as if the remote engineer can see it, if our local people can see it, and then we can communicate things through text or copy and paste things into text into Slack. That's the penultimate, right, of communication to solve things.
So in regard to the network, you were telling me off camera that you had a bit of an amazing migration that was basically seamless. Can you talk a little bit about that?
Yes, I would say sweat equity would be the right the right term. So we've been around for 15 years, so we have a pretty substantial data center deployment, many cabs, tens of thousands of clients, and the name of the game in any hosting arena is going to be uptime, right? And so from the very beginning, even you look back 10, 15 years ago, we were designing top of rack to be in multiple ways would be redundant. So you have you have a primary public, you have a secondary public. Those are on separate switches, and each switch has redundant connections. And so everything that we design on top of rack is designed for uptime. But what that helped us do was when we recently made a switch this year to spine and leaf architecture, and what that allowed us to do was pull out a switch with no downtime, insert the leaf, right, and then fail over to that leaf as if nothing ever happened for the client, right? So the client notices nothing. You don't have to put out a maintenance notice. There's nothing in that realm that needs to be worried about. And as a matter of fact, if that secondary switch or that leaf were to be unplugged, it would just fail back over to the primary. And so we were able to swap out our entire network. And when I say entire network, I don't just mean the switches. I mean all the fiber. We built a new core cab that was running simultaneously with the old core cab, and we were able to completely replace our network across every client. I think we took like maybe 3 or 4 days to do it, but there was not a single hiccup during that entire replacement. So top of rack completely switched out for a new network, and the old network is now somewhere being burnt in a big fire. So try. No, we donate devices, and we don't burn things, but yeah. So all servers are on rails, right? Yeah. Utilize Supermicro rails. You probably know this is all blank space here, but this is all because we want the airflow to not go through these open spaces. We want them to go through the servers themselves, right?
But I did want to show you, I put this as an example. I did put this server in here. This is not a production server, but it'll give you an idea of like how we diagnose servers in the rack. So instead of having to unbolt it, we kind of leave these not bolted in. Yeah. And basically just take them out to the second mark. Right? There you go. You just fix them right on the spot. So whether it's replacing the fan, replacing a CPU, replacing a PSU. This one had a rate card in it. Again, this is not production. But we keep it real simple. We don't even take it out all the way out of the rack. We just slide it forward. Then pop back on. Back in.
Like many of us in the field, James loves working in data centers, but he's quick to point out that real data centers are nothing like what you see on TV.
So maybe a little bit of a random topic, a random little tidbit of information here. Over the years, I remember growing up and thinking, oh, these data centers are these like mysterious clean rooms, and they look a certain way. And I quickly realized that what's on TV versus what an actual operational working data center looks like is completely different, right? So when I think about what we do here on a day-to-day basis, there's the things that everyone talks about is like power and computers and servers and hot swappable drives. But the reality is, it's almost like, and this is a super strange analogy, but it's almost like a market, right? Like a fish market or something. You have constant inventory that's moving in and out. There's like cardboard boxes that are shipping in like 100 servers in a single day, and you have to get them all racked. And there's old inventory being cycled out. Like even this last year, we actually revamped our entire network, so we reran all new fiber for that. And so everything is when an operational data center, when you see it, it's almost like, I guess the analogy would be almost like a battleship, right? Sort of like a submarine. You have this, you walk in and there's like pipes everywhere, and in the ceiling there's all this power running everywhere, an enormous amount of power, and there's just constant change. So today we might be filming a few things, but you come back in a week and things look completely different. There may be new switches, there may be new hardware. We may swap out entire cabs at PDUs, whatever it might be. Things are changing constantly. It's constantly in flux. And you have to stay up with times too. So you're trying to think ahead with inventory. You're trying to think ahead of how to stay relevant when you run that hardware. And I think that's one thing that I think as a clients don't actually get to see. They just expect their website to be online all the time, and they shouldn't. They shouldn't have to think about what happens behind the scenes. But what actually goes on is very complex. And so I know as a company, as BigScoots, we purposely wanted to have an office. That we're in the office right now, but we purposely wanted to have an office in our data center spaces. And so, we have that control, right? We have the control to switch out components, to make changes for clients, whatever it may be. So that's kind of a weird thing to talk about, but it's really behind the scenes makes a big difference as to what, the delivery to our clients and the general operation of the data center.
With client demand, keeping up with the load is crucial. BigScoots sees regular scaling, with new servers being added regularly in order to keep up with the demand.
So one of the things we need to be always aware of in the data center, it's great that we have great infrastructure here, that we have, great power and cooling and everything else. But one of the things we always need to be aware of is space is gold in the data center, right? So if let's say you have 50 cabinets, right? Well, if your business is growing, what happens when you need 100 cabinets, right? So, for us at least, when we're working with a data center, we always have a ramp in mind. So we're trying to project what we're going to need on year 2, year 3, year 4, year 5, and stay ahead of that. And so even in a space like this, which you're probably going to see, shots of cabinets, those walls will over time get pulled down and expanded out because we have guaranteed ramps in the data center to get to where we need to be for space. So, if we have an X percentage of growth, we're trying to calculate it out, project that out. And, for at least the next 5 years, we know that even in this facility here, we're going to have the space to naturally grow into. And so that's kind of how that works.
So James, what tips do you have for system administrators out there that are just getting into the job?
Yeah, so I guess two ways of looking at this, right? So you have, from a data center perspective, you have, DC techs, and then on the opposite end, from the keyboard perspective, you have system admins, right? And so this may be kind of an unconventional approach to this, and it might be a little bit I'm sure it'll be maybe controversial as well. But when we talk about certifications, right? There's a lot of value in certifications. I think that education is super important. I think that certifications are super important. But the reality of the whole thing is that a lot of companies work differently. They use different tools. They have different management portals, or they're working with different operating systems, different flavors of Linux, and different hardware, right? And so what it boils down to is that maybe 30 to 50% is learned before you join a company. And then when you're actually on the job, there's so much more to learn, right? It's always, I find that even from like a day-to-day, a month-to-month perspective, we're adapting new tools. And so all of our employees have to kind of continually educate, right? We have to like support each other, and what are the trends, what are happening, kind of backdoors are there out there, security issues, plug-in conflicts. It could come back even back down to hardware, right? We talk a lot about BMC and IPMI. There's a lot of things that are constantly changing that you have to keep up with. And so my suggestion is, yes, go always be educating yourself from a certificate standpoint, but really the most important thing is that when you walk into a position like that you're willing to learn, that it's not just, yes, you have your job, but, make sure that it's your life interest, right? That you really want to be solving problems, remain inquisitive. And one of the unconventional approach to this is that many years ago, I would, resumes would come in, and you would have someone who's been in the industry for 20 years, and they're very rigid in their ways of doing things. But then you might have someone that come in and they'd have like, a degree in philosophy, right? A degree in history, or maybe they wanted to be a teacher and that wasn't working out for them. Those people actually make great sysadmins, because it's beyond just customer service. They want to find out why things work. They want to solve the questions of the universe, or in this case, Alma Linux, right? They want to really get into the nuts and bolts and figure things out. And so I think when you take an approach like that, someone who wants to learn, even if they don't have the experience, and just help them get there a little bit, and then they can propel themselves into a situation where they become rock stars.
And where can people go to learn more about BigScoots?
Obviously, website. So BigScoots.com is the easiest place to go. I mean, we're, we travel around to shows like CloudFest, and we go to Tastemakers. There's like several shows throughout the year. We are based, this is our office right here, but we're based out of Chicago. So that's our home base. But really, we have a remote, talk about like, employees out of Europe, employees out of Canada, all over the U.S., out of Pakistan, India, like all full-time employees that we use. And we're very proud of our global presence, I guess you'd say.
BigScoots is a fully managed WordPress hosting and performance service provider known for its exceptional reliability and speed. Operating its own infrastructure, BigScoots ensures full control over performance and security, making it an ideal choice for enterprise WordPress and WooCommerce hosting. With proactive monitoring and skilled professionals at the helm, BigScoots meets the needs of even the most demanding businesses. Visit the URL that you see on the screen right now to check them out. I had a lot of fun here at the BigScoots Datacenter. It was an incredible experience. I love being in data centers, being surrounded by technology. It was incredible. Definitely check out BigScoots at BigScoots.com to see what they're up to. And thank you guys so much for watching my video. I really appreciate it. Let me know in the comments down below what you thought of this video, and I look forward to seeing you in the next video.